my presentation. And welcome again to the HAProxy conference. And thanks for HAProxy for providing me this chance to present my solution. Today I will talk about deploying HAProxy in Kubernetes using only single SSL and single domain. Here's my outline. Today I will actually introduce some key points which are important to provide better services, and also I will bore you with some definitions. After that, I will introduce my architecture, which will actually combine each of these key points and items frameworks in together to achieve our aims, and then I will present my implementation, which will include the combination of these aims, and then I will conclude my presentation with the future ideas. So let's start with what is the service. Service is an application that is enhanced in a way to exchange information through the network. And there are multiple protocols that can exchange for an application through the network in multiple layers, such as HTTP, HTTPS, UDP, and so on. So one of the widely used is HTTPS, which implements TLS SSL over HTTP. And today we will use that protocol to achieve our aim. So we defined what is the service. So service needs to be highly available in order to ensure that let's assume that we have lots of stakeholders, lots of consumers and applications using our services. So provide them to ensure that they are getting the best quality services. We need to actually provide high availability and some certain metrics, some fixed metrics to ensure that they are getting the best quality service. So in general, those metrics are stated in service level agreements, and high availability actually help us to provide better services, such as helping reducing the downtime, and also it helps us to improve nearly all of our non-functional requirements, such as robustness, reliability, and resilience. And we are generally measuring the high availability with the downtime measure within a certain period of time. So how can we achieve high availability? Actually, there are multiple approaches and tools to achieve this, but the load balancers are the key tool to achieve and provide high availability to our services. And when we talk about load balancers are actually tools that use algorithms such as round robin to make our services highly available, as well as increase our performance, consistency, and as well as I mentioned, it reducing our downtime. And actually our failure rates, since it's reducing the downtime. So let's simply talk about what is the proxy and reverse proxy servers do. Actually, proxy servers are a middleware tool that's in the middle between our client and the internet. It provides security and anonymity between client and the internet providers, internet web pages, and in this way we are keeping anonymous while we are connected to the internet. And what is reverse proxy do is exactly reverse of what proxy servers do. It's welcoming all the incoming requests to our system, and it actually adding some layers on it to provide encrypted communication between client and the internet. And actually it's welcoming all of the requests, and also in this way we have always a certain type of server in between our application services with the client that cannot be reached directly from the client side, and in this way we will define all the services, and only those defined services can be reachable from the outside world. So reverse proxies are not enough for provide each of the security constraints to provide better services, and we need some actually additional features on the top of the reverse proxy features, and these actually tools generally called as API gateways, and API gateways is like a gatekeeper between our services and the outside world application, we can call it stakeholders, clients. And when I say additional features, it's like security features, like limiting number of requests, and also IP whitelisting. Now I bored you with multiple definitions. We can think of our gateway as gatekeepers, as pillars of the king, and we will actually give a client list to our gatekeepers, and the kings will always keep in that capacity, and also we will give a capacity of, for example, 100 people, then our kingdom will always have 100 people at a certain time t. So now we have a problem. What our problem is, to provide better services, we need to actually maintain the services in highly available manner, and we need to load balance each of the incoming requests to overcome the overload, and actually we need to provide a security layer to, such as using proxy servers, reverse proxy servers, to make secure communication between client and our services, and we need to introduce a gateway to route incoming requests to the corresponding services. So it's look like too much maintenance because it can be actually maintained by different tools. These items can be maintained by different tools, but it's not actually require too much maintenance. We will see that it is applicable with HAProxy and Kubernetes using single SSL and single domain. Let's deep dive into architecture. We will have lots of services. It can be at any scale, but to simplify it, I actually added only 6 services, and our HAProxy will run in the Kubernetes, but our services can be at any environment like cloud, in company, on-premise, and also it can be running on Docker, it can be running on Kubernetes. It doesn't matter for us. And we will only use single SSL and single domain to reach all of our services. Because in our days, like microservice architecture or in machine learning, in data systems, we have lots of services doing lots of different jobs. So they can be running on, again, Docker, and this architecture will provide a solution to achieve it. So how will we reach from a single entry point to each of our services? So let's go step by step, and we need to map each of our services to a certain path within the URL. So let's say our domain is xyz.com. Then we need to map each of our services. For example, service 1 can be reachable from /service1 and service 2 same, and so on. So let's see those mappings within our architecture. So if you call xyz.com /service1, it will directly route to our service ones. So in this way, HAProxy will act as an API gateway and route all the incoming requests to corresponding services. And again, it can be in any environment, because, for example, if you use Kubernetes ingress, and then we can only route those incoming requests within the Kubernetes. In this way, we are extending our environments, like it can be run on bare metal, it can be run on Docker. So how HAProxy provide high availability with load balancing feature? Let's only focus on service 1. We have service 1 running on the in our company, on-premise environment, and also in cloud providers. It can be any cloud providers, as long as it can be reachable through the network. So when I said when we are highly available, for example, think of the internet service providers having some troubles to provide a stable internet to our company. So if any of the requests routed in those paths to our company, it will fail, and it will actually make our stakeholders very sad. With using the HAProxy load balancing feature, HAProxy will actually always check all of these services with an interval stated in the configuration or in a default way, and will not route any of the incoming requests to those services, and it always route in our cloud environment, and yeah, we will have very happy stakeholders, and we will have high availability. Of course, in the cloud environment, the services need to be adjusted to conform the same amount of requests at time t, while the half of our system are down, and our stakeholders even didn't realize that we have huge problem. So let's take a closer look how load balancing works. For example, think of we set to use algorithm round robin, and it will actually check each of instances for service one, and it will actually distribute the load in a circular way, like after instance, and it will go to the instance one, and so on. Now, most of us think, what if HAProxy fails? If HAProxy fails in our architecture, actually, it will lead us to single point of failure. So how can we overcome? Not overcome, because we cannot eliminate the single point of failure, but we can reduce the probability to happen. So this will, again, single point of failure will lead us to the very sad stakeholders. So if we deploy HAProxy in Kubernetes, it will actually reduce the probability of single failure with certain rules, like horizontal pod auto-scaling. And please note that I will not include any scaling implementation in my presentation. We had a very great presentation yesterday presented by Ryan from Docker, and it actually well explained how can you scale your HAProxy within the Kubernetes. And also we will have a use of deployments, which actually will provide us to have a number of instances at any time for our stakeholders. And we will, of course, use of deployment scenarios, such as rolling update, which is actually default in Kubernetes. But if you are into open source, I can suggest that CNCF Argo rollouts, which is actually covering nearly all the best practice deployments within Kubernetes in Kubernetes native. And we will have actually a deployment with cost and time efficient at any scale. And of course, we will have very happy stakeholders, since we will always be available. So let's dive into implementation. In implementation, I actually did a very small example for the globals. These globals help us to actually define for all the parameters in global parameter. For example, I set for maximum connection count to 50K, and also I set diff Hellman parameter to 2048. And we all know that the higher bits means the better encryptions. And with HAProxy, with the ACL feature of and the petback option of ACL feature of HAProxy, we can provide this routing only with 2 lines of configuration. Of course, it can be generated dynamically, but to simplify it, I added only 3 services. And with these 3 services, for example, if the incoming request contains /service1 at the end, then it will route to our corresponding backend, the service 1. And it is same as service 2 and service 3. And we can also define a default backend, which can be web server that handling all the other requests, or it can be a simple sending message like you are trying to reach the undefined path or unrelevant path. And you can always check out the HAProxy web page for all the other configuration parameters. And in defaults, I defined like connection parameters. It seems like, this is just an example for you can set these timeout parameter regarding to your aim and regarding to your use case. And we are using log global. But here, important thing is we are actually terminating SSL with reverse proxy. Within the HAProxy, we are actually mounting our certificate file, and we are binding to some certain port with the mode of HTTP. And if any request incoming without this certificate, it will fail. And we can think of the front end is like our front door opening to internet, and every request come through our system will always hit to this front end. So let's define our services. It's very simple, and you can of course, define mode and balance parameter in the globals, in defaults, sorry. But since nowadays we have lots of services using different protocols, I defined them under each services. So you can define with reachable IP, port, and the service name. And there are lots of options in HAProxy to like check, and the other options you can add regarding to your aim. And now we have actually a list of servers that can, HAProxy will be load balancing between them. And yeah. So let's continue with the key generation. So we need to prepare the key file in order to use within the HAProxy. So do not actually think this path will be strict. Please start where your key file is stated in, or your key file extension will state it in. So we will start with JKS, which is Java key store file. If you are using Java application to end your SSL and terminate your SSL, this is where you will start. So after that, we will create our P12 file. And from P12 file, we will create our key and certificate file. Then we will combine them into a PAM file, which will be ready to use by HAProxy. So let's see how this happened. And let's see how JKS converted into the P12 file. We will actually using key tool command line to actually convert our Java key store file to P12 file. And then for the P12 file to key and certificate generation, we will again use OpenSSL command line. And please use passphrase while generating your certificate always. And now we will have key file and certificate file in a single place. And after that, we are combining our key and certificate file into a PAM file. Now it is ready to use by our HAProxy. So now we are creating config map from our HAProxy configuration, which is created earlier, and we are creating secrets which are encrypted version of config map within the Kubernetes. Now it can be used by any HAProxy deployed within the Kubernetes cluster. And then we need to create a service which can be actually provide a front-end layer to be accessible by our services. So after applying these configuration YAML, we will have connection between our HAProxy and our domain. So if you are using cloud, I would prefer not node port, load balancer to achieve it. So if you again apply the load balancer within your with this configuration, you will get a connection with the domain and the HAProxy. Now we are seeing the deployment. And in deployment, we have replica count, which is actually Kubernetes will ensure that the HAProxy will always have a certain replicas within the cluster. And also, we are importing our configuration file as well as our secret file, key file, in order to use by HAProxy. In this way, actually, HAProxy have a state in the configuration file. Since we are using config maps, it will actually act as stateless within the Kubernetes cluster. And after applying our deployment, the HAProxy will start running within the Kubernetes. So for conclusion, we see that how can we make our service highly available, prevent single point of failure, and also managing API gateway and load balancer in a single place. And we deployed this architecture only using single SSL and single domain. And we did it with only a single application called HAProxy. And it helped us to reduce our downtime, maintenance, and of course, the cost of SSL and domain for each of our services if we are providing it in a different domain. So for future improvements, we can actually automate the generation of configuration file, adding to each service or service rule into our configuration file. And of course, we can support with some CI/CD features and for the HAProxy deployment and HAProxy configuration deployment within the Kubernetes. And also, we can apply some Kubernetes role-based access control in order to increase our authorization layer within Kubernetes in order to access to HAProxy. And my references. Thank you for listening.